So my name is Maarten Dirkse. I'm going to be talking about my company, or the company I work at, bol.com, and how we went to the cloud and what that means for us and what we are doing in the cloud. Let's get started. The agenda here is, first I'll talk a bit about bol.com, about me. Then going to the cloud part will be the why and also when. So why did we go to the cloud and when did we start doing that? Then the how. Then we'll talk about CI/CD, because after all this is the CI/CD meetup. Then I'll talk a bit about the current state of the cloud migration that we're in the middle of. And then finally, if we have some time left, some time for questions, but feel free to also ask questions during any of these topics, because, well, I'm not very strict. First of all, though, how many people here have themselves run or have had a hand in running something in the cloud? Doesn't matter which cloud. Okay, that's all right. How many people that did not raise their hand would like to do this one day? I'm kind of expecting the rest of you to now raise your hand. Yes, excellent. Great, the perfect audience. All right. So, about bol.com. So, most people that live in Holland know about bol.com, but most people that live in Turkey do not. We are the largest online retailer in the Netherlands and in Flanders, the Dutch-speaking part of Belgium. We have about 8 million customers and 18 million products. And we have, in terms of IT, we have 60 plus Scrum teams, 400 plus engineers, and 300 plus application services that we run. And we're growing at a pretty impressive pace. I joined the company 6 years ago, a little more than 6 years ago, and at that time the entire company was as large as the IT department is now, so you can get a sense of how fast we're actually growing. And then about me, you can find me on Twitter here. I started out as a Java developer at bol.com, and then I spent some time on the CI/CD team, where I was a colleague of Patrick, one of the organizers of this meetup. And then finally in August this year I became the company's first and only to date cloud advocate, which means that internally I try to get people enthusiastic about going to the cloud, and externally I try to get people enthusiastic about how we are going to the cloud. So that's what I'm doing today. And finally, because of my time on the CI/CD team, I have a special fondness for CI/CD and also for containers. So I'll be talking a little bit about that as well. Right. Why did bol.com go to the cloud? So just to give you kind of sketch of our current situation. So we're in the middle of the cloud migration, but most of our applications still run in our own data center. And by our own, I mean we rent space and electricity from the company Amsterdam, and we place our servers there, and that's where we run our website from, or most of our website. And we decided at a certain point that we needed to move to the cloud. And why did we decide that? Because we came to two really important realizations. First of all, we realized that bol.com is a retail platform company and not an IT platform company. So we build a platform that allows us and allows our sellers and our partners to sell stuff to consumers, to our customers. That is our core business. Our core business is not setting up a data center, running IT infrastructure, and making sure all that stuff stays patched and with the correct quality, etc., etc. That is not our core business, but that is what we are doing at the moment, because we have our own DC. So that's realization number one. Realization number two was that we learned that we can't out-innovate public cloud provider platforms. We don't have the money to do that, we don't have the people to do that, we don't have the time to do that, and most importantly, it is not in our interest to do that. And we did try for certain things, because for a lot of things you can say like, well, you don't need to duplicate the entire cloud platform provided by Microsoft or AWS or Google. You just need to have the things that you really need, and then you can build those yourselves, and then you can run on that, and you forget about all the stuff that you don't need. Well, yeah, you could do that, but even those parts that you just need, for example, internally we try to build a container platform It took a lot of time, a lot of energy, a lot of people doing stuff, working on it that could have been working on other things. And when it was done, it wasn't nearly up to the quality or at nearly the feature set of the publicly available container platforms like GKE or the various options that AWS has. Azure Kubernetes platform, for instance. So it worked in the end, but the feature set was really, really constrained. And as soon as it was sort of released, so to speak, it was already outdated, and we were kind of behind the curve. So even if we just focus on what we need as a company, we still can't out-innovate public cloud platform providers. So those two realizations, we don't want to build IT platforms, and even if we did, there's no way we could compete with Google, Amazon, and Microsoft. So then we decided we needed to move to the cloud, because if we move to the cloud, then we get all the advantages that I just spoke about, and we can focus on our core business. So we decided about a year and a half ago that we would move to the Google Cloud. So I have this slide about we love running on GCP because I should mention, because most people at this point ask, like, that sounds logical, but why did you move to the Google Cloud and why not to Amazon or Microsoft? Sorry?
AWS is the biggest market presence in the cloud. I think.
Yeah. So I mean, AWS has the biggest market share. So in general, we moved to GCP, but we moved to a public cloud provider, and we love it because it's like literally like having thousands of engineers developing your platform. Google invests like many times our total yearly revenues in their cloud platform, and we get to use all that stuff. They develop it, and obviously you have to pay for it, but it's all available to us. So that's really great. It gives you the freedom of managed, which essentially means that Google takes care of a lot of the annoying work for you, which leaves you free to actually do what you want to do, namely build a retail platform. So for example, OS patching for VMs, container vulnerability scanning, all of the stuff that you otherwise have to manage yourself. Google actually manages for you, giving you lots of time to do other stuff. And GCP has a pretty good focus on machine learning and Kubernetes. I'll talk about that a bit more in a bit. And it was chosen by our engineers. So back to the question, why not AWS or Azure? So I didn't put this on the slide, but I'm going to say it on YouTube now anyway, so it doesn't matter. We didn't choose Amazon because Amazon is like our biggest competitor, or potentially one of our biggest competitors. Amazon is an online retailer, we're an online retailer, and despite the fact that weird things would probably never happen, our management was not too comfortable about running our entire business in a data center of somebody who is in direct competition with us. So that was AWS out of the question. Then there was the question of Azure, and Azure was actually a very serious option for us because our parent company Ahold, which is a huge holding company, also a Dutch company, already has a contract with Azure and is running all kinds of stuff there. So I said, well, this is all well and good, but can't you guys just piggyback on our contract? And that'll be that. But in the end, we were already experimenting with Google Cloud, and it came down to the fact that our engineers who were actually using these tools and using the platforms really liked Google Cloud, and also liked the whole ethos that, the open source ethos that Google has, and the way that they are developer centered. So it kind of gave us a warm and fuzzy feeling inside. So we said, well, because there's not that much difference between the cloud platforms, and only in the details, doesn't everything. They all have Kubernetes providers, they all provide VMs, etc., etc. We were going to go with Google Cloud Platform. So that's why we love running on Google Cloud, and that's why we are running on Google Cloud and not on Microsoft and or on AWS. Yeah.
Is there any way to reason the choosing Google because of you are also the retail company, e-commerce, and Google is good in that one, AdSense or something like that?
No, that didn't really factor into the decision, no. No. We have like some sort of relationship with Google on the commercial side because we export our data to Google Shopping, but that had nothing to do with the decision to go to GCP. So, once that decision was made, how do we want to go to the cloud? Right. So we have a couple of basic principles that we defined that we wanted to guide use to guide our entry and migration to the cloud. So we start with we want to run everything in containers. Like in our current setup in the data center, we run everything on VMs. That has all the usual drawbacks. So we said, okay, we're going to run everything in Kubernetes unless we have a really good reason to not run it on Kubernetes. And that really good reason could be that we have some sort of third-party application that absolutely refuses to run in a container, then we run it on VMs. But otherwise, we run everything in a container. We use managed services for everything. So we don't want to reinvent any wheel that Google has already spent much more time and money than we ever could inventing for us. So if there's a managed service for it, use that managed service, and don't reinvent the wheel ourselves. Don't set up our own container orchestration layer. Don't try to run our own BI tooling on VMs, etc., etc. Use the stuff that Google manages for you. Then, very important, total team autonomy. So, on the CI/CD team, we are on the CI/CD team. I have to say they now because I'm no longer on the team. But we used to like the joke that we want everything to be self-service because we don't really want to talk to our users. We'd rather just they solve their own problems and not bother us too much. So everything should be self-service. The users should be able to do everything that they need to get their work done themselves. And that's not the case in the data center at the moment. There are several hoops you have to jump through. You have to wait for other people. And even if that waiting takes next to no time at all, it's still a pretty big psychological barrier to doing your work. So everything should be self-service. Teams should be able to do everything that they need to do to get their work done themselves without having to rely on other people. That was really important. The paved road experience. Paved road is an expression you hear a lot where the idea is that the sort of usual experience that satisfies the requirements of 80% of the teams on your platform should be like completely smooth and really easy. So a lot of convention over configuration stuff, like a lot of best practices baked into the platform, a lot of stuff that is managed for you. If you want to go and actually go under the hood and tinker with stuff, you can. But if you just have like a normal application that has a database backend and is a web service, then your experience should be like really, really smooth. And then from security, we had this requirement of 2 layers of defense. So I don't know if you're familiar with this, but then you have like a login and a firewall that the login is behind. So you have, if the hackers go through one layer, then they still have another layer to go through. We have that in the data center, and they really wanted to have that in the Google Cloud as well. That took a bit of effort to actually implement, but we're on our way. And finally, we want everything as code. So infrastructure is code, and yeah, your code is code as well, obviously. But everything in Git repositories and reproducible so that we have good disaster recovery in case, well, in the cloud, so in our data center we have to deal with the risk that the data center somehow, we always talk about, what if a plane lands on the data center? The data center is gone and we have to rebuild it. Well, when you're running in the cloud, you don't so much have to deal with the risk of your data center disappearing. It's more like you have to deal with the risk of somebody accidentally deleting your stuff, and then you have to be able to recreate it. Because of the way Google manages most things, it's nicely distributed and fault tolerant, etc., but that still doesn't protect you from somebody just hitting the delete button by accident. So everything is code, mostly for disaster recovery and reproducibility. So those are the basic principles that we defined at the beginning. So the tooling. So there's a bunch of tooling out there that will help you actually set up your infrastructure in the cloud. And one of the best known and one of the best tools that is cloud agnostic is Terraform. Raise your hand if you have heard of or used Terraform. Okay. so Terraform is great because it allows you to abstract all those cloud resources and allows you to roll them out in a kind of declarative way, which and there's plenty of people use it. It's been tested quite extensively. But the problem is it really exposes like the entire cloud platform to you, and you can do almost anything with it. And from the beginning, we kind of realized that just giving our Scrum teams Terraform and saying like, good luck, here's the documentation, here's the cloud stuff you can define, was probably not going to be a huge success because first of all, there's a giant learning curve, and second, there's a lot of stuff in the Google Cloud Platform that by default is not set up the way we'd like. So by default, if you create a VM, it has a public IP. And actually one of our security engineers, just for fun, kind of created a VM with a public IP and then logged the incoming SSH login attempts. And within an hour, he had people from like the Seychelles and Cuba and I don't know where, like trying to log into this public IP. So there are several measures that we wanted to take with these cloud resources to make them more secure, or to make sure that they conform to our best practices. Which, if you have to do that in Terraform from scratch, it's difficult. And if you have to do that in a way that you have to like have Terraform templates, etc., it also makes it more difficult. So we decided not to do that. Well, not quite, but we decided not to give our users Terraform. We decided to give our users something else. This is R2-D2 from Star Wars. We developed a tool in-house called R2-D2. The reason it's called R2-D2, it's some sort of like terrible acronym, which I can't quite remember, but there was a reason why we called it R2-D2. And R2-D2 is a tool that we give to the feature teams with which they can actually deploy their cloud resources in a self-service manner. So how does it work? Well, it uses YAML files, which is either unfortunate or really handy, depending on how you look at it, but in any case, it uses YAML files with which people can define resources. So here, I'm not sure if it's legible, but here you have an application project, and then you have a configuration for a deployment tool called Spinnaker, and then you have a service account and a storage bucket, and we now have close to 30 different resources that you can define using this tool. And basically, the workflow is a user writes YAML, writes this tool, writes this YAML file, feeds it to R2-D2 via a CI/CD pipeline, and then R2-D2 actually, under the hood, generates Terraform files and then applies those to the Google Cloud. So then you have your infrastructure as code in these R2-D2 files, which live in the same repository as your application, and it makes your entire infrastructure pipeline repeatable in essence. So, gateway drugs. A couple of the things that we really used heavily from the beginning. The things that really drew us to Google Cloud, and that from the beginning we said, well, we were going to base a large part of our cloud operations on these products. Kubernetes, so Google Kubernetes Engine, totally managed Kubernetes solution. Like I said, we decided very early on we were going to run everything on containers and run those containers on Kubernetes. You may know that Google is a company in which the 3 engineers that actually came up with Kubernetes worked.
And I thought that is the reason why you selected Google Cloud, because they were really started very early to managing this Kubernetes thing on cloud. I mean, yeah, much better than AWS and Azure as well. I think you didn't say implied or underline it, but that might be one of the reasons why you selected Google Cloud.
That's true. Yeah. They had Kubernetes support very early on.
Yes.
And managed Kubernetes support. So AWS and Microsoft have done a pretty good job of catching up, and some might say that they're actually further along now with the Kubernetes support than Google itself is, because they have serverless Kubernetes. But anyway, so the 3 guys that came up with Kubernetes worked at Google, so obviously Google is kind of obliged to have a really good Kubernetes offering, and GKE is really good. So we use that to run all of our containers. Then we have, this is the logo for BigQuery, which is Google's BI solution, which is awesome. And we pipe all of our business data, or nearly all of it, almost all of it by now, into BigQuery, and then we expose it to business users that can run like ad hoc queries and all kinds of reporting. We have this whole reporting stack that runs on a product called AdScale, made by a company called Tableau, or a product called Tableau made by a company called AdScale. I can never tell which one is which. But in any case, and it's totally based on BigQuery, and it's made all of our stuff like, I don't know how much faster, and also a lot more scalable, because BigQuery is totally serverless. So it parallelizes your queries so that you get kind of really fast response rates. Yeah.
Yeah, my company is looking at starting to use BigQuery
Yeah.
for analytics. How much effort did you have to do to optimize that? Did you? I don't know. I mean, we're struggling with some of the features that BigQuery brings to the table, like
Yeah.
clustering, partitioning, and nested tables. All those features that are not your standard SQL. So, did you have to go through a heavy learning curve? Did you suddenly do queries that cost you thousands of euros, that kind of stuff, or?
No. So we had the situation in which our old BI platform was end of life, and I think the manufacturer had said like, okay, we're not supporting this anymore, so we had to move off of it. We moved to BigQuery and Tableau AdScale, and when we were ramping up the Tableau AdScale usage within the company, we hit a couple of scalability bottlenecks that were on the Tableau side, which had to do with how it was using BigQuery scalability in terms of the processing time, but also in terms of the cost. So we had a bunch of people from that company come in and actually like optimize our usage of BigQuery. Apart from that, we already had a BI setup where we had our applications stream all their data into Hadoop, HBase, all these kinds of clustering solutions. And we just basically redirected those streams to BigQuery and used the same kind of mechanics to get the data out. And there we did learn some difficult lessons, difficult in the sense that they were really expensive because people weren't paying attention to the fact that they were scanning like the entire data set when they didn't really have to, and thus were paying 100 euros per cycle. But yeah, we have fairly vigilant cost controllers at the company, or at least some people that really kind of take a look at how much the BigQuery costs are, how much BigQuery usage is costing, so that we don't make those mistakes too often. I guess we had this we had a team who took their Hadoop jobs from our own BI infrastructure and then ran them sort of unmodified in the cloud using one of Google's Hadoop solutions, and they weren't really paying attention, and then they were running it like 3 times a day, and it turned out that it was costing them 2,000 euros a day to run it, because when they spun up their job it cost like, or it used 46 VMs or something for 10 hours, and then they reworked the whole thing to run on BigQuery, and then instead of 10 hours it took 30 seconds, and instead of 2,000 euros it cost 50 cents. So, so in that sense, rather than costing a lot more money, BigQuery is giving us a lot of chance to optimize our data usage, I guess.
I think I want to take it.
Sorry?
Carry on, because now we're.
Oh, right, yeah, sorry. So, BigQuery will reduce your cost by a factor of, no, just kidding. And then finally, so TensorFlow is kind of a symbol for all the machine learning stuff that Google has, which has been used a lot by our data scientists, which they build models for things like obviously the standard retail things like recommendations, etc., etc. But so I'll just give one example. We have a service that figures out how our order picker should walk in our warehouse, and using the Google ML various ML products, they were able to develop this model that actually saved like 450 walking hours over the last like 2 or 3 months or something. And they were able to develop that really quickly because of all the tooling. So those are the sort of gateway drugs, and obviously behind the gateway drugs, if you really become like a heavy user, there's all kinds of other stuff that's really awesome as well. But these are the 3 things that at the outset were really important. So I'll talk a little bit about the containers and how we set up our Kubernetes clusters. So we employ this methodology which I have termed Kubernetes service compartmentalization, and that essentially means that we have a Kubernetes setup that has different Kubernetes clusters for staging and production. No God mode accounts, because we limit everything to service accounts which have just enough rights to do what they want to do or what they need to do. And then we have a namespace in Kubernetes per and a Google Container Registry repository per application per cluster. And that's kind of it's not a very usual setup, as I've learned since we did this, because most people have like one namespace for production and one namespace for staging or something along those lines, or a namespace per team. We actually give every application its own little world to exist in, and that helps with isolation, obviously, namespace isolation within Kubernetes. It helps with resource management, because you can assign quotas for memory and for CPU and usage, that sort of thing, to the namespaces. It also helps for billing. Google is actually developing, so this, I'm not sure it's there quite yet, but they're developing per namespace billing options for your Kubernetes cluster, so you can actually select which application costs what. And obviously, if something goes terribly wrong inside a namespace, then it is confined to that namespace and it won't take down all the other applications also running on your cluster. So it's a bit of a different setup, and it takes a lot of management, but we have most of that management automated to a fairly comfortable degree, and it has some pretty important advantages. And we are working on Istio integration. If you haven't heard of Istio, then you haven't been reading cloud news for the past 6 months, a year probably, because most of the talk is about Istio and service meshes. So we're working on integrating that, and that is in progress. Right. CI/CD. Given the fact that this is the CI/CD meetup, I thought I should talk a bit about CI/CD. So, in the data center, the way we run stuff now, and the way we still run most of our stuff, is as follows. So we have Jenkins, which does our builds. The builds yield artifacts. So if they are Java builds, then they yield jars, and if they are Golang builds, which we also have, then they yield binaries, Golang binaries. Those are stored in Artifactory. Then we have Rundeck, which is basically a distributed script runner, which actually takes care of getting those artifacts, baking an RPM, so a Red Hat package out of them. And then we have Puppet, which runs on all of our VMs. Like I said, in DC, every application runs on a VM, and we usually have 2 instances of that VM for high availability purposes. Puppet actually goes in and makes sure that those RPMs are rolled out to the servers involved in whatever servers you are developing. So Jenkins, Artifactory, and then Rundeck, Puppet, and this is how we deploy software. However, Jenkins is a maintenance nightmare, and I know because I had to maintain it for the past 5 years. And just in case you're thinking to yourself, Jenkins isn't so bad, go have a talk with Patrick. Patrick is a card-carrying member of the anti-Jenkins brigades, and he will convince you that Jenkins is a terrible idea to run. Artifactory. You can use Artifactory as a Docker registry, but you have to manage it yourself, and also it's a pretty expensive Docker registry. If you actually go and look at the pricing, it's not that cheap. Then you have Rundeck, Rundeck is not a deployment tool. So Rundeck is, like I said, a distributed script runner. It's essentially a way to run scripts on a bunch of machines and with some orchestration around it, but it is emphatically not a deployment tool. It has no notion of what a deployment is or anything, it just runs jobs. And then you have Puppet. So Puppet actually rolls out our stuff to VMs, but it does that in a way that we provision the VMs once, and then when we have software updates, they are updated in place. And of course, you can re-provision the VMs, but the usual way to update it is to take the old version, get rid of it, and then install the new version. And what you actually want is immutable infrastructure. So you actually want to re-provision VMs on every go, but that takes way too long. That means your deploys would take like half an hour, 45 minutes in some cases, because the Puppet has to run from scratch. So we don't do that. We replace the software in place, and that's of course not what you want, because you run the risk that you get configuration drift, etc., etc. So the current stack, the legacy stack, it would work in the cloud as well. If we're being honest, I mean, do we really have to reinvent the whole thing? Did we really have to reinvent it? No, the current stack would have worked, but we thought that we could do a lot better by using cloud-native tooling. So that's what we did. So this is the new stack, the cloud stack. For doing builds, we have GitLab CI. If you hear Patrick's story about why Jenkins is terrible, and you hear him out on that, then the next story he'll tell will be about how great GitLab CI is. So talk to him afterwards if you want to know more. And then we have, yeah?
You don't use the cloud version, do you? Use
No, we host that
on-premise?
ourselves. Yeah, we host it ourselves because of, well, we host it ourselves because of various reasons, but among them security. But yeah, we use a self-hosted version. And we use Google Cloud Builder, or Cloud Build rather, which is the that particular item. And Cloud Build solved the problem of building Docker containers for us. So, if you want to build Docker containers, there's all kinds of ways to do it, but most of them involve being root on whatever machine it is that you build them on. Google Cloud Build allows you to actually outsource that problem to Google, and they give you a VM that spins up specifically for your build use case, that builds the container and pushes it to a Google container registry. And then you don't have to worry about Docker containers and Docker daemons running on your own machines, which is fantastic. So GitLab CI and Cloud Build. Then we have Google Container Registry, which is a Docker container registry that runs on Google storage infrastructure, which means that it's totally managed by Google, not our problem. Fantastic. Spinnaker, which is a deployment tool that is. Raise your hand if you've heard of Spinnaker. Right. That's about the, yeah. So yeah, it's gaining in name recognition, I guess, slowly but steadily. But most audiences are still like pretty unsure about it. But it's a tool that was developed by Netflix and by Google to do cloud-native deployment. And then finally, Kubernetes, which runs Docker containers for us, as I said before. So, GitLab CI, more developer control, because you can, GitLab CI uses the kind of Travis CI model where you define your builds in a YAML file in your repository. And a lot less maintenance by a DPI, the CI/CD team inside. That's what we call the CI/CD team at pool.com. So no more maintenance nightmare as with Jenkins. Google Cloud Registry, Google can take care of it. Fine, just manage it for us. And that's it. Spinnaker is an actual deployment tool. It has first-class primitives for doing deployments and dealing with artifacts and doing rollbacks, all that kind of thing. It's really great because it actually reasons about deployments as opposed to being a scripting tool that allows you to run scripts. And then finally, Kubernetes with the containers actually gives us that immutable infrastructure that we're looking for, because you don't upgrade anything in a container in place, you just build a new container and run it. So that's what we're running at the moment in the cloud. Then a bit about the current state. So what do we now actually do in the cloud right now as of this moment? So we have about 30 plus services running production on the Google Cloud as we speak. You might think that's a lot, you might not, but if I tell you that's out of about 450 services, then you're probably going to say that's not that much. That's true, but the big push for migration will be in 2019. We've been kind of gearing up the different tooling, using a couple teams as kind of beta testers, and then 2019 we're planning to do a big push of company-wide to get as many services onto Google Cloud as we can on a pool basis. So we want to convince teams that they should move to the cloud because of the advantages it has for them. We don't want to actually tell teams like you will now move to the cloud. It's important. We have about 3/4 of our BI needs served by BigQuery. Like I said, Tableau at scale, there's a whole bunch of stuff that still runs on our legacy systems, which are more or less falling over now in the data center because there's no investment being done in them anymore. So there's kind of a need to move the rest to BigQuery as well. But for now, 3/4 and most of the important stuff is actually done on BigQuery. And then we have a whole bunch of machine learning success stories that were sort of aided by the Google tooling in that space. I told you about the warehouse pickers. There's a bunch of other stories like that where people have been able to use Google tooling to very quickly develop models and use ML in our own products, in our own services. And finally, teams are very much enjoying their newfound autonomy. So we had one of the success stories we tell internally is that there was a team who developed a new service and brought it to production in 3 days, whereas in the old in the DC, if they were to try that, it would have taken them at least probably 2 to 3 weeks due to the fact that they had to wait for VM provisioning, etc., etc. So that's a big win for a lot of teams, that they have a lot more autonomy, don't have to wait around for anybody anymore, and can just sort of realize their ideas in a very, very quick manner. And they like that. So some lessons learned so far from the migration. Make sure that any homegrown deployment tooling is rock solid. This is me trying to be gentle about the fact that R2D2 has not always been the most stable of tools, and because of the fact that not that many people use it yet inside the company, or at least the usage is pretty wide, but for a very narrow use case, it's not been that annoying. But if you develop this kind of tool that your entire company will use, and this, you might say like, yeah, Maarten, that sounds pretty obvious, but still it bears repeating. Make sure that it's really, really solid and you don't like publish breaking changes, etc., etc. If the entire company depends on it. Figure out a plan to migrate quickly and then get management sponsorship as soon as possible. So one of the things we kind of had a problem with in the beginning was that management thought, well, all these engineers are pretty smart, so we'll kind of let them figure out the cloud thing and then we'll just do whatever they came up with. That works as long as the engineers actually come up with something, but if the engineers have 5 different opinions and can't figure out amongst themselves which should be the way to go, then actually management has to step in and make a decision, because that's what they're for. And if they don't, then you kind of keep going around in circles for a while until you realize that you're wasting your own time and you have to actually make decisions. So, and this is kind of my personal opinion as well, but I think it's really helpful if management gets on board with a particular vision for the cloud and your company in the cloud, and sort of becomes a real sponsor and a real advocate of that vision from the very beginning, so that people know exactly where you're going. And then finally, some things that that we experienced running the stack that we have now. So Spinnaker at scale can be a pretty big challenge to operate. It's operated at huge scale by Netflix, and they do all kinds of special things. But because of the setup we have with the multiple Kubernetes namespaces, it also we hit a couple of scalability limits pretty quickly. And finally, give everybody their own GitLab runner. What I mean by that is, so this is kind of a stupid detail. Well, not stupid, but this is kind of a minor detail, but something that was really genius, because in the old setup we had Jenkins slaves. So I'm assuming everybody knows what Jenkins slaves are. Is that a fair assumption? No? Yes? No?
I don't.
Oh, you don't? Okay. Right. So the way Jenkins works is you give it a build, and then there's a whole bunch of slaves kind of waiting around for new builds to be serviced. And what always happens is that you hit a certain point where you have too many slaves, or you have too few slaves actually service every request coming in. But then the problem is that if you over-provision these slaves, most of them are sitting around doing nothing until you hit these peak loads. And with Kubernetes and with GitLab, you can actually say, well, we're going to give every single team their own slave, which only exists when there's actually something to run, and they will never run out of resources, because whenever they need to run something, it will be there for them to run. So this was like I feel a bit stupid telling you about this, to be honest, because this was like this huge problem that we had in the CI/CD team, and telling you about it now kind of makes you realize it's probably not relevant for a lot of other people in a lot of other spaces. But that was like a kind of a eureka moment for us. And Kubernetes and the way that GitLab is set up to use Kubernetes actually lets you do that in a very nice way.
So it's every team that has its own runner?
Yeah, every team has its own runner. Yeah.
So it's not that you run a runner on your laptop that can also hook up to GitLab?
No.
Yes.
Well,
You can.
probably not ever, because security would be very comfortable with that particular solution. But no, so no, yeah. We use the cloud resources, so it essentially use Kubernetes to be able to scale to the necessary whatever load is currently on GitLab.
Well, I can imagine that for your iOS app, you would run it on a Mac or so.
Yeah, so yes, that's true. But to be honest, our iOS team is kind of weird, and they're off in their own little world doing their iOS thing anyway, so we don't really know what's going on there. So, they don't run on this stuff, or at least not yet. So, but yeah, you're right. That would be that would make sense. Yeah. That's it. That's all I have. Thank you very much. We're hiring in case you would like to work on this stuff with us. We have an English language job site, careers.bol.com. Yeah. Are there any questions? Yes.
For this R2D tool,
Yeah.
first of all, is it? Do you have any plan to open it, open source of it, put it somewhere?
Right. So we discussed that quite a bit, and there's also we're not the only ones that made a tool like that. So there's a lot of companies that developed something similar, and there's a couple of approaches you could take. So we take the YAML file and we transform it to Terraform. Another approach is to use Kubernetes CRDs. So you have custom resources in Kubernetes that allow you to define cloud infrastructure. So Amazon just launched something that supports that workflow, and I think Shopify developed a framework that does that. Eventually the conclusion that we came to is that there is so much stuff in there that is so specific to how we want to run things that it would be, first of all, it would be really hard to untangle all the bull stuff from it. And second, if we do that, then the added value will be very limited. Because for us, all the added value is in the fact that we take these manifests and we deploy Google Cloud resources in a way that we want to deploy them, and with all of our best practices and security concerns baked in. And if those are not your best practices and security concerns, then the tool becomes pretty much useless for you. So, as of now, we have no plans to open source it.
Question.
Yeah.
So you talk about how you're using your cloud infrastructure and how you're pushing your new products and code to the cloud environment.
Mm-hmm.
So where your testing is coming here, like have you created your automation scripts in a containerized application? You're setting your left, like you don't need a specific test environment, but you put it in a container and running the script itself in your cloud infrastructure hand in hand. You have some kind of arrangement yet?
Some kind of, sorry?
Arrangement yet to test
Yeah.
your, yeah?
So there's two things. First of all, we use a GitLab feature called, I forget. Wait, the GitLab feature that allows you to spin up temporary environments. What's it called again?
App preview?
Oh, review apps.
Review apps, thank you. A GitLab ritual review apps, which essentially allows you to spin up like a mini environment with your application, and have some supporting containers that provide like a database to test against, or stubbed REST endpoints, that sort of thing. So that's one. The second is, so I should say there's three things. That's one. The second is we have a staging environment, but the staging environment is such that you can launch like any amount of applications on there that you'd like. So if you want to have 3 different versions of your application running at the same time on staging, you can do that. So it's like an infinite amount of test environments you can spin up on staging. And then finally, we're really trying to move to a point where we kind of do away with the staging environment and start testing as much as possible in production, using techniques like canary releases and that sort of thing because I have strong opinions about this, but I think acceptance environments are just like a hoax basically, because they give you this false sense of confidence which then falls apart when you go to production. So it's much better to test in the actual, in the one environment that you have that is actually production-like, which is production. And we have the techniques to do that, like canary testing, so that's actually much better than trying to make yourself feel good about your software by running it in acceptance and doing some sort of automated tests. Obviously there's a kind of balance between how much you should test in your build pipeline and how much you should test in production, but as a company we're really trying to move more towards this testing and production stuff, as opposed to creating all kinds of test environments to run our stuff there.
Just a follow-up to that question from my friend here. You showed the difference as to how you moved from the legacy way of doing things to the new way of doing things. How much of that consideration was based on how you test and how much you test? I mean, it's also about the amount of coverage that you're trying to achieve with testing, right? So
it's a good question. It was a factor, especially in choosing to go with Spinnaker and Kubernetes, because it's so easy to create like kind of mini environments that you can use to test. Yeah, I guess that's the answer. Yeah, so it was a factor in that sense, but and we knew that using Kubernetes we could scale up our automated testing in a way that was much easier than we do it in our data center at the moment, which is by essentially having a whole bunch of VMs that the tests run on. For example, our automated GUI tests and stuff, they need to run on actual VMs, and we knew that in the cloud we'd be able to do it on containers, and Kubernetes would make that a lot easier. So yeah, in that sense it was a factor. Yeah. Any other questions? Wait, I'll go to you first, sorry.
So you said that you joined Bol.com 6 years, and
yeah.
Then at some point turned to the cloud, managing, or at least you were the cloud advocate.
Yes.
From how long have you been doing that? So since
August.
August this year?
Cloud advocate, yeah, since August this year.
No, what I mean is starting to try the cloud environment to replace your applications.
Right.
Did it take you 1 year from starting some experiments to production?
It took us, so from starting experiments to actually running something in production took a year. And then we had one service running in production. That's for the service part. So for the data part, the BI part, they had actually already started earlier, because at first the idea was we used the cloud to solve our data problem, because we were getting tired of running Hadoop ourselves, essentially. That had already started earlier, and the actual value from that was already being generated a bit earlier as well. But on the service side, from idea to running something in production took about a year.
And a follow-up question is, was it kind of a learning on the job process, or did you take some kind of training from Google? It was just experimenting yourselves?
Yeah, it was really teaching ourselves cloud, essentially, to a degree that if I now look back, I would probably say that was kind of irresponsible and probably made it so that it took a lot longer than it might have. but yeah, it was completely a self-taught thing, because one of the at the outset, one of the constraints that we had was that we couldn't like increase the headcount for the infrastructure and platform teams, so we couldn't like hire a whole bunch of people to come help us. So we had to do it ourselves essentially.
So no help from Google?
Not until fairly late in the process. So at a certain point we got a support contract, and then we had a technical account manager who comes and comes to the office once a week and sits with us the entire day and helps us with whatever questions we have. And obviously, you know, we have support from Google in terms of tickets and that sort of thing.
Yeah.
But that actually, we got that probably too late. We could have gotten that a lot earlier, and it would have helped. So. Yeah.
But at least you are now in good touch with them.
Yeah, definitely. So yeah, and it's really helped. So it's really helped not only in the technical aspect of things, as you would expect. Like they can help you if you say like, well, I'm missing this feature in you know this product, and they say, well, you know, the feature will be there. The feature will be there in a couple months or something along those lines. Or that's interesting. We never thought of that. We're going to build it for you. That's also happened a couple of times. But also in terms of the organizational aspect, how do you go about adopting the cloud? How do you go about making that adoption a success? Getting people to feel good about the migration, etc., etc. They have a lot of experience doing that with different companies, obviously, not least in their own company. So that really helps as well. Yes.
Are you experiencing a shift in your knowledge base, per se, for the workforce? So suddenly this creates the divide between the actual layer 7 software development versus the actually mid-layer infrastructure development in that respect, and the knowledge divide will become wider. I don't know if you start experiencing this, or you're saying we are hiring, for example. Are you willing to hire at the point that, for example, all the company members started basically knowing nothing and start teaching yourself into a cloud environment? Or right now you're at the point of you would like to hire people who already have some form of certification or already hands-on in there? Or are you willing to hire people in a different profile for your IT or let me say infrastructure team, then hire people with different skill sets for the actual software team, which will go into some sort of container later on?
Right. That's a really good question. So the point we are at now as a company is that we have a whole bunch of teams that are not yet running anything in the cloud, not yet running any services in the cloud. So right now it would be kind of weird to demand that everybody we hire has some sort of cloud experience, because it might be that they end up in a team that will not go to the cloud with anything for the next like 6 to 9 months. So why would you insist on that? In general, it would be nice to have only candidates that already have some sort of experience running cloud services, but that's not really realistic, I guess. And you said that there's this divide between running the infrastructure and running the application. That divide was already present in our old setup. We had essentially an operations team that was responsible for running the infrastructure and responsible for running applications up until the application server level, and the feature teams were only responsible for writing the actual application. And with the move to the cloud, especially with the move to containers, that's sort of been turned on its head, because with containers you, as an application team, suddenly become responsible for the entire stack from the kernel to the actual application, whereas before you were only responsible for the application and the operations team was responsible for everything that came beneath that. So teams now find themselves with a lot more responsibility if they wanted to run their own kind of applications than they had before. So that divide is still there, but it shifted down the stack essentially.
In a sense, previously you were already handling contracts within the company between the developers and the ops, but
yeah.
Right now your DevOps has a new member in the field, it's Google. So even somebody decides what needs to be done in the in a Docker container, let's say, but then somebody has to handle how the Kubernetes is going to shift its way. So
Right.
you might need to just redefine some of the parameters, how the Kubernetes handles itself
Yeah.
for the orchestration and so.
Right.
So suddenly yes, you can just shift some of the knowledge from the old, let me say, infrastructure to the core app development team, but now you have a gap. You need somebody to talk with the Google actually for them to handle your business.
Yeah.
And it also includes additional kind of challenges like the query type of extra expensive query you've
Yeah.
been having. You could afford that query because you already paid for it. You have the machine, it is just staying there. If you run it 30 seconds 3 times a day, or if you run it 10 hours twice a day.
Exactly.
Right now, it changes. Suddenly, you don't have the machine, you only pay a dime or a big G in
Yeah.
there suddenly. It actually changes the more than the business side of it. It is more money. I'm asking these questions because once you say that I am the advocate, it is not just only the hype of the technology upcoming.
Well,
If it doesn't
mostly,
make
but
the-
yeah.
if it doesn't make the money, if it is cheaper to run everything in-house, nobody will go and just do it for the cloud because somebody said it is cloud.
Yeah, that's totally true. Unfortunately, no, that's completely true. And the last example you gave is actually really pertinent because I was speaking to one of the IT directors the other day, and he said, "Well, in the data center, we kind of have a natural cost cap, right? Things cannot cost more than we have resources for because we have a finite amount of resources. If you want to run a Hadoop job." It's going to cost at most a certain amount of euros because we just don't have any more resources. In the cloud, where the resources are to all intents and purposes infinite, you can actually spend a giant amount of money in a very short time. And then the question becomes, the natural cost controls that you have in a data center because of the finite resources, are those so beneficial to your company that they are to be preferred to the risk of spending a giant amount of money in the cloud. And I think, and of course I'm a cloud advocate, so I'm paid to think this, but I think that in the end, you should opt for the model where you have you really kind of watch your spend, but still have this possibility to, if you need to, really scale up without having to do all kinds of investments up front, and because that's the other thing. I mean, you say we have, we've already paid for these machines in the data center, and you've already paid for the query that you're running, but at night when you're not running any queries, you're still paying for that machine, whereas in the cloud you're not. So it gives you a kind of elasticity also in your cost that is, if you handle it well, can really benefit you in terms of the situation, and as opposed to the situation in the data center. But it takes kind of so I don't know if you're familiar with this expression, like the price of democracy is eternal vigilance, like the price of cloud elasticity is eternal cost vigilance, I guess. You always have to watch how much you spend, whereas in the data center nobody cares, right? I mean, people care, but that's the other thing. With the billing stuff that we have in the cloud now, you can actually go to a team and say, okay, your application costs this amount of money. In the data center, nobody knows because people hardly know how much their application or how much the servers cost that they're running on. And then to be able to calculate, okay, you're running on this piece of hardware which has like 60 VMs, 2 of which are yours, and then nobody has any idea what that costs. Whereas in the cloud, you really know what the stuff costs. So you can actually do stuff like give teams a budget and that kind of thing as well. So yeah.
So are you implementing any kind of vigilance to the teams, saying that you should improve on your development skills?
Yeah. So we
because they have ownership on their application, so they should be responsible also for what they spend.
Yeah. So that that tooling, the tooling that we have around that is still kind of in its infancy. We started out with a bunch of dashboards that give teams insight into the cost of their application, and every team can kind of go in and see, okay, what am I spending per day in the cloud, or per week, or per month. The sort of, oh my God, you're spending thousands of euros an hour, please stop, kind of controls are still done by a person looking at the costs every day, so that's not ideal. So we have to still develop a bunch of tooling around that, and also Google is also actively developing a bunch of tooling around that helps you actually put caps on the spending or something like that. Then you have to kind of, it's difficult, right? Because you could put a cap on spending, and then what do? You turn off the project, and so then one of the production services goes down because they cost too much money now. So it's tricky, but yeah, and like I said, we're still at the kind of the beginning phase of actually getting that stuff in place. Yes.
Dus R2D2.
I'm sorry?
R2D2.
Yeah.
Got my attention. Does it expose the state of Terraform? Does the user?
The Terraform state file?
Yeah.
No. What you can do is what's your
Not necessarily the file, but that's actually the state.
Oh right. So yeah,
are they aware of what they deploy and?
It has, or it will have very shortly, an API that you can actually use to query the state of your resources. Yeah. But this is but not the actual Terraform state file, because also it runs Terraform a bunch of times. It doesn't do like one big Terraform run. It does a bunch of small Terraform runs. But you can query that from the API server, which may or may not exist just yet. Yeah. Yes.
Let me see. So what in your infrastructure in the ball.com portfolio?
Yep.
I imagine you must have some transactional database.
Yes.
And have you given some thought to how that is that still running your data center? Are you moving into the cloud, and if so, have you thought about how?
Yes, no, and yes. So in our data center we run a bunch of databases, but most notably we run a lot of Oracle and a lot of Postgres. Oracle cannot be moved to the cloud because the licensing won't allow it. So and Postgres obviously can because it's open source. And also Google has a bunch of or has a hosted Postgres solution called Cloud SQL. So for the services that are running on Postgres, we're encouraging them to move to Cloud SQL, or at least Postgres in the cloud, and they can kind of migrate as is because they're using a database that will translate to the cloud quite easily. For the Oracle stuff, it's a bit more difficult, not only because we can't run Oracle in the cloud, so they have to migrate their application from Oracle to Postgres, but also because a lot of the Oracle-based applications have some application logic in the database itself, in the PL SQL code. And obviously, that won't. We're not going to migrate that in any form to the cloud. That logic needs to come out of the database and into the application, and before it can actually before they can transition to Postgres and then move to the cloud. So we're kind of waiting to see how many teams will actually do what I just described, or will actually choose to kind of implement small parts of the original service as new Postgres-backed services in the cloud and kind of hollow out the original service instead of actually migrating the entire thing. And then there's a bunch of Google portfolio databases that we use in the cloud as well, like Google Data Store, which is a NoSQL document store essentially, and Spanner, which is Spanner is essentially a SQL database, but with global consistency and availability. So those are two of the better known products in the Google data portfolio that we use.
I heard Spanner, you cannot really do normal SQL to it, you need to use an API. That's what I heard.
No, I think you can do, that's, so, so Google has Data Store, which is eventually consistent, And then they figured out that eventually consistent kind of sucks for some use cases, so they just decided to solve the whole consistency and global availability problem using like atomic clocks and all kinds of things. But they actually have an SQL interface. You can actually write SQL queries. So there's also an API, obviously, that you can use to approach it, but you can also just write SQL queries.
This is what I heard, the crowdsourcing.
Yes.
What base Docker image is used? And
Which based? Yes, that's a good question, and one that reminds me of a lot of pain and endless discussions about which base image. Yeah. So in the data center, we run everything on Red Hat. So our first kind of impulse was to use a CentOS base image because that's kind of what we knew. It had all the familiar tooling, and also because we are hooked into the whole Red Hat security update stuff, then we would know when there's a security issue in the Red Hat base images or the CentOS base images and be able to update stuff. But then we had all kinds of developers who were like, this is stupid, why can't I just use Alpine or Debian, or why do I have to use Red Hat, and the base image is 450 megabytes, you know, it's way too big, etc., etc. And then finally we said, well, okay, we're going to allow teams to use a different base image as long as they yeah, sorry about that. As long as they kind of keep track of the whole security stuff themselves, which is workable, but puts a lot of effort with the team to actually, you know, make sure that their Alpine images are not way out of date with all kinds of security holes in them. So that wasn't really workable either. So the approach we have now is that we have Google Container Scanning, and we have a solution called Aquasec, if I'm not mistaken, which also does container scanning, which will actually go in and figure out if there are vulnerabilities in your container, regardless of which base image you use, and regardless of, you know, if you're using Debian or Alpine or whatever. So now people are actually free to do whatever the hell they want, because we know that the tooling will actually come in and figure out if there are any vulnerabilities in there. So that's, you know, I guess the best of all worlds, because now people are totally free, but still we can maintain a secure operating layer on in terms of container images.
Yeah, if the tool does detect a vulnerability, it's kind of first priority call. Team needs to fix that as soon as possible, or how?
Yeah, so I would love to say yes, but we're not quite there yet with the procedures.
Okay.
So yeah, that is the idea, but we're not quite. We don't really have the sort of procedures in place yet to actually deal with it. Yeah. So yeah, but that is the end goal. And there's also a bunch of Kubernetes tooling that is being developed that will actually allow you to say, well, if there's an image which has so first of all, images need to be scanned before they can be deployed in the cluster.
Oh, yeah.
And then if they haven't been scanned and there are vulnerabilities in them, then we're just not going to deploy them. So we don't use that yet, but that's also something that Aquasec will do free. So, yeah.
The scan
Yeah.
is done by the Kubernetes or some other kind of tools which scan the images?
It's done by other tools, which then sign the image in some way, so that agents running on the Kubernetes cluster can actually tell whether or not they are allowed to be deployed. So you have custom controllers running in the Kubernetes cluster that actually inspect the images looking for a particular signature, and if they don't find it, it doesn't get deployed, and if it does find it and it figures out that there are a bunch of vulnerabilities, then it doesn't get deployed either.
Follow-up question is like, there is a new way of working in containerization. I heard like you create a container itself inside a container, so container inside container. So
you create a container, you run a container inside a container?
So run a container inside a container, kind of.
We're also doing such a thing for one of the banks in London. They open in containers, but they're also using containers to deploy different containers as well. Yeah. That's something they're doing for real production. I mean, you know, for making deployment much easier. Yeah.
Okay. Yeah, you can do that, but then So in most of the approaches that do that, you need access to the Docker socket, which means you can root the machine. So that's kind of out of the question because security doesn't like it when you open that stuff up. So yeah.
One part of containerization is all actually wrapping everything up in the OS layer into the application. What is the challenge with the pen testing when it comes to that? Because right now we are discussing about picking the right, let's say, baked image or which baked image, but does your tool actually focusing only on the baked image, or is it focusing on the baked image plus the software included in there?
Yeah, it's focusing on the end product, so on the entire thing. So
an issue coming with the, let's say, baked image, but not the application. So normally you're still signing it off, or you have to update the whole image before you go review the test. And so I'm really looking for the test perspective specifically about the pen testing. Anybody actually doing the pen testing on the application you provide, or the baked image which was provided from some other resource?
So I'm not sure, but there's no. The way that the automated container scanning works is that it's not really penetration testing. It literally goes in and looks at all the files that are in the container on the container file system, and then checks against like a central database of known vulnerabilities. If your libc is out of date or something like that, or one of the jar files that you're using in your Java product has known vulnerabilities, that sort of thing. And it is scanning the end product. So every single application that creates a container image, that gets scanned, and then if there are errors in the base image, then a whole bunch of applications will then have a problem and have to go update their base image.
Okay, but at the end, it is not checking the logical or the business logic behind to see that if coding actually created a security vulnerability.
Right. So it's not seeing it's not running your container to check that you have like open ports that allow root exploit in the container, for instance. No, it's just scanning the file system.
Okay.
Yeah.
Thank you.
Have I finally exhausted all of you to the point where you have no more questions? Right. Then,
drinks.
Thank you once again, and if you have any more questions, feel free to contact me by email or Twitter or right after this presentation. Thanks.